All right, you guys cool on this page? All right, so let's talk about how to plot this first part on the first example. It's not too bad. Plot the number. I should say the complex number. Two minus 3i. So a complex number, all that is it's a part of the complex number system. So it's a real number or a imaginary number. Either one are in the complex plane. So once you combine the real numbers with the imaginaries, you create a two-dimensional plane called the complex plane. So when you combine those two together, you have all real numbers as part of that set and all imaginaries. Okay, so this is a complex number in that set. And when you plot it, all you got to do is have the real axis and the complex or the imaginary axis. So this is my real part, imaginary. So all you got to do is go out 1, 2, down 3. This is my point 2 minus 3i, the complex point. So very straightforward, right? So this is basically the real component and the imaginary component. Does that make sense? Any questions on example 1? There's not much else to say. All right, number 2, find the magnitude or absolute value of z equal to square root of 5 minus I. So the magnitude symbol or the absolute symbol are the same. So all you got to do is square the number parts, the a and the b, or the x and the y, same thing. So square the root 5 plus the -1 part, not the I, right? Just the numbers go in there, not the imaginary parts. So this will be 5 plus 1, which is root 6. Any questions about finding magnitude? So if you had this distance right here, let's say from here to here, that would be the magnitude, that length. So let me draw you a picture real quick. So if I were to, root 5 is what, about 2 point something, right? 2.2 maybe, I don't know. -1 is right here. So the point would be there. So this distance from here to here is root 6. This point is root 5 minus I. Okay, that makes sense? Yeah.
So do we just assume that I is 1?
Yeah, so there's a -1 on the I. Yeah, so if there's like a 2i, you only take the 2. If it's a -I, it's a -1. Any questions? Any other questions on 1 or 2? What's up? How did I what? Sorry. This part? The first one? Yes.
I don't-
Well, how do you plot it? Oh, okay, I'm sorry. Think I'm congested today. So root 5 is basically about 2 point something. So I'm guessing it's a little over 2. So this is like the real component. The imaginary is going to be up and down. So whatever is I will be up and down. So this is -1 I. So I went down 1. So this right here, erase that part. This is the point -1. This is right 1, 2, right? So the point I'm plotting is this one. So just like you would X and Y, pretend this is your X and your Y. Root 5, -1. But the length, the distance is root 6 though. They didn't ask us to plot. I just want you to see that what this means visually. Okay. Any other questions on number 2? Start it. All right. So we'll skip 3 because it's the same type of thing. Let's move on to number 4. You guys okay on this page?
Okay.
Yeah. Oh, gotcha. Okay. Number 4. So I'm going to name it 4, even though it's not from the book. Express this complex number in polar coordinates. All right. So they're giving us 4i. So there's no real component. Yeah. It's example 4 from the book, but we skipped 3 because it's the same thing as the last one. So rewrite this as z equal to 0 plus 4i. If there's no real number, it's understood to be 0. So if you plot this guy, we understand it'd be up here, right? So if you look at this, if you look at this as a unit circle, do you see that this is the 90-degree angle right there? Is that obvious? Because to go to polar, you need to use the formula we wrote earlier. Z is equal to R times cosine theta plus I sine theta. So you need the R and you need the theta. We said earlier that R is equal to this. So step 1 would be find the R. So that'll be 0 squared plus 4 squared, which is 4. R is 4. So number 2, we need to find theta. Now we can just look at it right there, right? Theta is equal to pi over 2 because of the location of where you plot. Now you could solve for it technically, but if you can see it, just use it. So plug it into the formula. 0 plus 4i as a polar, that would be simply 4 times cosine pi over 2 plus I sine pi over 2. So this is the polar form. Does that make sense? We're just using the formula, because if you simplify it, yeah. Oh, just well, if you look at your unit circle, right? This is 90 degrees. And this is where I plotted the point. 0, 4i is right here. So on your unit circle, what angle is this? It's gonna be this. Right, so if it landed over here, then it'd be 45. So on the next example, I'll show you how to find it. In case it's not obvious. Let's say it's a harder question where it's not right on the line. Change -4 plus 4i into polar. So step 1, let me write out the rules this time. Find r. R is equal to this. Uh, 4 squared, 16 plus 16, 32. This reduces to what? 4 root 2, right? So there's my r. Step 2, find theta. Theta is equal to tan inverse of y over x, which would be tan inverse of, what is that? 4 over -4. Which is what, -45, right? No. Interesting. Only one is negative, so it would be quadrant. Four. Tan inverse is only on the right half of the circle. Pi over 2 to pi over 2, so that'd be -45. But -45 is x negative there. Yeah, I don't think 10 would be the good one here. Calculator out. I'm curious now. 1 second. Yeah. Let's use cosine. Because if x is negative and y is positive, that's going to be a different quadrant, right? That's quadrant 2. So we could say that cosine theta is equal to x over r, which means theta is equal to cosine inverse. So that would give us theta equal to -4 over 4, which would be 3 pi over 4. Yeah. Yeah.
For the cosine inverse, it's x over
R. Yeah, I think that's where I'm messing it up. Because R would be 4√2. Which is the same answer, but here, let's show the work. This would be cosine inverse of -1/√2, which is cosine inverse of -√2/2, which is, yeah, 3/4. So you can use your calculator and you'll get this in degrees. You get in degrees. But anyway, so once you have that, just use the formula. Z is equal to R times cosine theta plus I sine theta. Or if you prefer, R times CIS theta, which will be 4√2 CIS 3/4. All right. Any question number 5? Sorry for that caused confusion. Step 1 is find R, and then find theta. You can find theta with sine, cosine, or tangent. But I chose cosine because we knew the answer was in quadrant 2. Tangent is restricted on quadrants 1 and 4, so switched it. Now going the other direction, convert polar to rectangular. All you got to do is really plug it in. So this would be equal to 12 cosine pi/6. So if we're changing this polar form into rectangular, just use your unit circle or calculator. So 12 cosine times of pi/6 right here would simply be 12 times cosine of pi/6. What is that? 3/2, right? Plus 1/2 I. Which will give us 6√3 plus 6I. Now 2 divided by 12 is 6 times that. 2 divided by 12 is 6. So when you distribute the 12, you get this. So polar to rectangular, all you do is you're just plugging in numbers. Okay. The other direction is a little more annoying because you got to find 2 parts. But once you find them, you just plug it in. Any questions on 5 or 6? Okay. Now let's do the multiplication and division using those formulas, that second set of formulas. That's cool on this page. All right. Find the product of Z1 times Z2 given given that Z1 equals 4 times cosine of 80 plus I sine 80, and Z2 is equal to 2 times cosine of 145 plus I sine 145. Okay, so Z1 times Z2. According to the formula, that's equal to R1 times R2 times the CIS thing, 80 plus, or sorry, theta 1 plus theta 2. So that would simply be 4 times 2 times cosine plus I sine theta 1 plus theta 2, which is 80 plus 145. Is this abbreviation okay? Is that confusing? The CIS? Don't forget what it means. It's just to save time. I've never seen a book use it before, but it's kind of nice, I guess. Basically, that would be what? Cosine 225, that's negative root 2 over 2 plus same thing over here, negative. Multiply the 8 through and you should get negative 4 root 2 minus 4 root 2I. Or if you prefer, you could put the I in front. Doesn't matter. Anyway, any question on number 8? That okay?
CIS means cosine.
Yeah, CIS means CIS of theta means cosine theta plus I sine theta. Just a shorthand. You don't have to write it that way. But if you see that in the book, that's what they mean. Okay. And it's in the formula page that we wrote down. Any other questions on number 8? It's not too bad so far, right? Nope. All right, number 9, find the quotient if Z1 is equal to 2 cosine of what they give me here, 213 plus I sine of 213, and Z2 is equal to 4 cosine 33 plus I sine 33. So Z1 divided by Z2 is a quotient. That's what they mean. That means you take R1 divided by R2 times the CIS of theta 1 minus theta 2. So that would be 2 over 4 times cosine of 213 minus 33. What is it? 180, right? Let's skip the minor step here. 213 minus 33 is this. Cosine of 180 on your unit circle, that's pi. So that'll be 1/2 times -1 plus 0. So the answer is -1/2. Any question on number 9? I'll do one last one and we'll call it a day. You guys cool on 8 and 9? Is it straightforward so far? Good. Okay, number 10, that's the, oh, wait a sec, sorry. Okay. Example 10. Evaluate one plus I to the 5th using De Moivre's theorem. So in order to use De Moivre's theorem, you need the R and theta. So R is equal to the square root of x squared plus y squared. So step 1 is find the R. This is root 2, right? 1 plus I. This is an I, by the way. The next thing is find theta. Theta will be equal to tan inverse of y over x, which is equal to 1 over 1. So tangent inverse of 1 over 1, which is pi over 4, right? 45 degrees. So at that point, you use the formula, De Moivre's formula. That says z to the n is equal to a plus bi to the n, which is r to the n times cosine n theta plus I sine n theta. So in our case, we have 1 plus I to the 5th. So our R is root 2, square root 2 to the 5th times cosine 5 times pi, or theta, 5 times theta. Okay. Root 2 to the 5th would be root 2 times root 2, which is a number 2. And then again, root 2 times root 2, that's 4. So this is 4 root 2. Cosine of 5 pi fourths, it's on the circle. That's going to be quadrant 3. So negative square root 2 over 2 plus negative square root 2 over 2i. Root 2 times root 2, that's a number 2. Root 2 times root 2, that's another number 2. So when you distribute this piece, I'll just be left with -1 and -1. So once you're done, you'll end up with this. So what this lets you do is instead of FOILing or multiplying 1 plus I 5 times with parentheses, you can just use this formula to send those powers into the angle. So the angle kind of absorbs the power and lets you simplify. So it's pretty handy if you have like, I don't know, some high powered function, or if you're like coding something, you're like, you know what, this takes less computing power compared to this, a power function versus a cyclical trig function. So those are ideas you could use. Like, all right, maybe I can just transform it into something that's more doable. Because depending on what you're doing, some computations can take days or hours, and some could take even years. So you may have to simplify things when you're doing applications. Okay. At least until we get quantum computing. All right, guys. Have any questions on this section? Is that okay? I've extended the homework to tomorrow night, 8-1, 8-2. The last 2 sections are due Sunday. Okay, this section and the last one. I think it's 8-3, 8-5, right? I believe so. No, no 4.